So I would say the CRA is incredibly interesting, and I would say somewhat terrifying if I was leading it, so I'm happy not to be leading it. We looked at System Bio as this idea that all of us in the branch levels and the CRA levels are really good at data collection experiments for what we're looking for, right? We're really good at that. And ultimately the Air Force wants this, right? I would say our big 30-year dream is this holistic model that you could just say, hey, if you go into this war environment, these are all the things that can happen to you. This is what's going to happen. Here's a risk assessment, and you got a 10% chance of dying, and this is why. And it'll be tox that kills you before DE kills you. That's probably what the Air Force is looking for us to do: is treat the human as a widget, and what could happen to this widget downstream. What's the lifetime of this widget? In 20 years, am I going to have medical expenses? All this stuff is where we want to be, right? Well, SysBio sits in that problem space where we have a bunch of discrete data. We got to put it into this holistic model. And the best thing about that, especially nowadays within the last 10 years, of course, I'm old, so I don't know about deep learning, but deep learning gives you these ideas of pattern recognition that's unseen, right? The computer sees something you don't see. So in my experiment, I'm never going to see what would happen if I translated my data to somebody that brought in multiple data sets and then saw this weird pattern. None of us will see that pattern, right? I'm not going to see it, you're not going to see it. When you put it all together, you start to see these weird patterns, and then you realize that the reason why you're tired is because you're from North Europe, and you didn't eat a lot of potatoes, and for you specifically, that's real bad. But other people in the cohort weren't tired, and that it has something to do with, this weird thing that we didn't think about at the time. So that's why I kind of made a really bad infographic about where I think SysBio really works, is putting these things together in this large thing, and that's, again, why it's terrifying. Again, I look at SysBio, obviously we have components that are very bottom up. My group is also very bottom up. Here's what we're doing, here's where we look, let's go up. I think SysBio has the opportunity to take things as a top-down response. And that means if something comes down from a YouTube pilot or something where they have, an abnormality, right? That's a very top-level problem. We have a clinical outcome, we have something. There's about 10 to hundreds of things that could be feeding that problem, as Dr. Hussain talked about. There's all these things that are going on in that cockpit. And each one of us knows one of them. But I think this group can really look at a top-down approach in some ways by compiling data and really looking at maybe the highest risk or highest likelihood. So that's what we talked about, gap identification from a holistic approach, especially in a rapid response environment. So the closer we get to this model, the faster you can respond to these things. It's highest probability to look at. Where do we put our money? Where do we put our time? Well, okay, hypoxia might be the best guess. Let's go there first, rule it out, and move down the list. So for some examples, that's what I was talking about, non-obvious data collection, things like I said, diet information. So if you're doing YouTube pilots, maybe diet has something to do with it, but you never collected that data. And the reason why you didn't collect that data is because you have a System Bio person saying, look, there's other things that are really easy to ask about that might be the key to what you're looking at. Another example is 23andMe like analysis. That's kind of a generic way to say it. But things for MN performance, like, what's your background? Where do your genetics come from? And as we've learned this over the last 10 or 15 years, and now it's, you just buy one if you want, you find out a lot about yourself if you look at where you came from, and obviously the Air Force is incredibly diverse. So we always say we have a very unique population set that's very controlled in age and everything, but we don't control lineage, right? There's things that need to come into these larger models. So that's what we came up with.
Okay, thank you.